In 1949, the famous science fiction author Robert Heinlein created a language for his novella Gulf that was meant to be spoken by a secret society of people with superhuman intelligence. He named his language Speedtalk because every letter, every phoneme in the language represented an entire word, allowing it to be spoken incredibly fast. This is that language. Or, not exactly. This is my interpretation of the language with a modern understanding of both conlanging and mathematics. I was surprised to learn that, as far as I can tell, no one has actually constructed Speedtalk properly. A couple of people have made things like Speedtalk, including John Quijada's Ithquil and Ben Sandler's quote-unquote crackpot scheme, but no one has reconstructed Speedtalk based on Heinlein's original novella. And to that I said, challenge accepted. This video is based on a classic science fiction story, but it also is a story, a detective story. This is my quest to discover Robert Heinlein's Speedtalk. It all started in the dim and distant past of 2022, when I said in my podcast episode about conlangs that the number of distinct sounds that can theoretically be produced by the human voice could run into the tens of thousands. Already plenty of words to make a language. I didn't do anything else with it at the time, but this was the first seed of an idea of how I might, perhaps, build Speedtalk for myself. Then came 2024, when the case well and truly landed on my desk. When Agma Schwa announced the third cursed conlang circus, and I took up the mantle again. Because any language as alien as Speedtalk would assuredly be cursed. I did a more rigorous calculation than before, and I discovered that my earlier guess was a gross underestimate. I now believe that the actual number of phonemes that can be produced by the human voice is over 1 million. Surely this was the way. It then transpired that this was completely irrelevant, because my first mistake was that I should have read Gulf before I started. And in the novella, Heinlein clearly states that Speedtalk only has 1,000 phonemes, and it handles vocabulary very differently. Heinlein doesn't give the exact number, probably because it was 1949 and computer science as we know it didn't exist yet, but clearly any sensible superhuman society would make it 1,024 phonemes. That was when I realized that I needed to be more rigorous about this to actually build Speedtalk as Heinlein intended it. I would have to build it piece by piece, no matter where the leads took me. And trust me, they took me to some weird places. So I buckled in and took the first step. What does Heinlein actually tell us about Speedtalk's phonology? I started hunting for clues in Heinlein's story, but unfortunately there weren't many to be found. At least not compared with the 1,024 phonemes there were supposed to be. The precise patterns he used to get that many consonants and vowels eluded me, or more likely, he never figured them out in the first place. We only see a couple dozen of Speedtalk's phonemes written out, and those are transcribed inaccurately by a non-speaker. But Heinlein does give us some clues in the main character Joe's language lessons. First, Speedtalk has phonemic vowel length and gemination. And I immediately thought that doesn't sound like the fastest way to do it. The fastest way would be to make them all short. But in a theme that will come up multiple times, Heinlein didn't have access to information theory. Claude Shannon had only discovered it the previous year, so he didn't have the mathematical knowledge to do things optimally. But of course, length wasn't the full story. Speedtalk is also a tonal language, and not just with level tones, but also contour tones. And it has phonemic stress. But here I had to disagree. Stress is a supersegmental that applies to syllables. You can't stress a single phoneme, can you? And yet, Heinlein seems to be pointing at phoneme-level phonemic stress. I couldn't do it. Maybe there was a way, maybe it would even make it more cursed. But to have the language be speakable, I decided to reinterpret that stress as something Joe could plausibly misinterpret as stress, namely aspirated consonants. Oh, and if you're thinking, isn't tone also a supersegmental that applies to syllables and not phonemes? Just wait. But Heinlein gives us one more clue from his transcribed conversations. If you look at them, the ratio of consonants to vowels is more or less normal for a native English speaker. That's more important than you might think, because the other thing we know about Speedtalk's phonology is that Heinlein envisioned it to be of middling exoticness. He does write, quote, some of the vowel and consonant sequences were very difficult to pronounce, but he also says the massive phonology was achieved, quote, without much refinement of accepted phonetic practice. And even before he learned the language, Joe was able to imitate it enough to be partially understood, which honestly seems pretty improbable from the outset, but really serves to underscore how quote-unquote normal it must be. These were the clues I had to turn into a working phonology of 1024 phonemes. And here I broke with tradition and started with the vowels. The snippets of Speedtalk we see give us these vowels. Note the inclusion of 3 rounded-unrounded pairs and a lot of front vowels. If we allow all of the vowels with valid rounded-unrounded pairs to have them, we get these. If we allow all of the front vowels with a corresponding back vowel to have them, we get these. And yes, there are a couple of blank spots, but this is accepted phonetic practice. And of course, you've got to have a schwa. Although note that this is not a reduced vowel, it's just very mid. From this, Speedtalk's vowels are E, 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 U, U, E, E, O, E, O, O, A, A. That's 20 vowels in all. Now, brief sidebar, what about the orthography? What orthography do you use for Speedtalk when the language has 1,000 phonemes? Why, it's written in IPA, of course. And with capital letters used for loanwords because those aren't used in IPA. But we're not done yet because we also have length and tone. Speedtalk's vowels can have 2 lengths, short or long, and they can have any of these 9 tones. Note that we're still using IPA, but with diacritics, not tone letters. 20 times 2 times 9 is a total of 360 vowels. But the vowels were easy. The consonants were the hard part. I needed 664 of them to fill out the phonology, and I barely knew where to begin with them. All of Heinlein's clues led to a large vowel inventory. He barely even mentioned the consonants. And it would have been a lot easier to come up with 3 times as many vowels. Just add creaky and breathy voice and you're done. But remember what I said, Speedtalk has a normal consonant to vowel ratio. If I wanted to be faithful to Heinlein's vision, I had to come up with more consonants. I followed all the leads I could, venturing down the dark alleys of the IPA chart. If you dig deep enough, there turned out to be a lot to choose from, but even then it was a struggle to get to 664 on the back of gemination and co-articulation alone. It was possible, but it would take just about everything. And Heinlein said it wasn't supposed to get too weird. I needed a different approach. So I kept digging, and I eventually found the clue I needed to solve the puzzle. I asked myself, what happens to syllabic consonants in tonal languages? Remember how I said tone is normally a supersegmental? Not in Speedtalk. Speedtalk has tonal consonants, separate from tonal vowels. More specifically, Speedtalk has 57 basic consonants. M, N, 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 P, B, T, D, T, D, T, D, K, G, K, G, K, G, A, F, V, F, V, Th, Th, S, Z, Sh, J, Sh, J, 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 H, G, H, G, H, 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 R, 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 Y, Y, B, R, R, bra, la, ra, sha, ja, la, la. And just like with the vowels, these consonants can have variations. Each one can have up to 4 articulations: plain, aspirated, labialized, and either palatalized or velarized. Plus, the ones highlighted in red are ones that don't quite fit the pattern. That's 191. Then there's gemination. All the consonants that have a distinct length, the fricatives, approximants, and nasals, have short and long versions. Also, the trills are parsed as exclusively long. That's 316. And finally, every voiced nasal, approximant, fricative, and trill has phonemic tone. They only have 3 tones, high, middle, and low. But that, at last, was enough to get me to the required 664 consonants, 1,024 phonemes in all. Now, you may think a language with over 1,000 phonemes is already pretty cursed, but we're just getting started. We still have to put these phonemes together. I was hot on the trail, but there was plenty more trouble still to come. As soon as I solved the first part of the case, a new mystery arose, contained in the very solution to the previous one. You see, there was a problem lurking in the tonal consonants. In fact, there was a problem with using tonal vowels rather than syllables. What happens if you string together 2 vowels with different tones? The way Heinlein describes it, Speedtalk doesn't really have phonotactics. It does have traditional notions of syllables, and it seems like phonemes will usually be arranged into coherent syllables. But that's not always possible, and in theory, any sounds can occur in any order. I could see immediately it wasn't going to work. It didn't matter what Heinlein said. The clues were pointing me to only one conclusion, and that was that the language couldn't have phonemes going all willy-nilly. It had to have some structure. I had to apply tonotactics. Real word. There was a reason I gave vowels contour tones, but consonants only got level tones. The consonants still have 2 slots for different tones, but one of them is used for tone harmonization, where the tone at the end of one sound has to be the same as the start of the next sound. If you put a tonal consonant next to a vowel, whichever slot is touching the vowel, it can be the first one or the second one, has the same tone as the vowel, while the other slot is used for the consonant's level tone. If it's a consonant cluster, whichever slot is closer to the vowel is harmonized. If 2 vowels are next to each other, they also have to harmonize. This also means that any given consonant can have up to 5 different allophones, all of which can overlap with the allophones of other consonants, depending on the adjacent vowel. For example, ng can be realized as nga, 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 ang. The thing is, it sounded nice, but it still wasn't going to work. I couldn't just ignore the no phonotactics rule. These phonemes aren't just phonemes, they're words. What if a sentence were such that you had to put 2 words with clashing tones next to each other? I finally decided that the answer was to set aside 2 spacer phonemes that don't have any semantic meaning but are only used to break up forbidden clusters. The spacer for vowels is the plain glottal stop, So, if you have 2 vowels with clashing phonemes, like you add the spacer to form And the same problem can occur with consonants if you have to string a bunch of them together. I allowed for a flexible syllable structure. Any sound that has phonemic length can serve as a syllable nucleus, with highest sonority taking precedence. And that even works in English with sounds like pst and pft. But what if you had a bunch of plosives in a row? Take the number 197,757, for example. In Speedtalk's number system, I'll come back to that later, it would be pronounced b-g-d. Maybe you'd call that pronounceable, maybe you wouldn't, but it's not really a syllable. To make it a syllable, we add the spacer for consonants, which is the short mid-tone schwa, to form bgd. Also, there are some other nuances and guidelines I learned from doing the translations. And that was it. I had one of the most cursed phonologies I'd ever seen. And yet, just when I thought I understood the language, Heinlein snatched it away again, taunting me from beyond the grave with bad 1940s philosophy. Because the grammar he assigned to his language was literal pseudoscience. While he doesn't call it by that name, Heinlein all but confirms that Speedtalk's grammar is based on something called general semantics. General semantics is a real-world philosophical system that was in vogue when Gulf was written. It purports to be a logical, scientific way of looking at the world, but later thinkers lampooned it as a pseudoscientific self-help system. I'll go a long way in pursuit of a case, but I wasn't about to make the effort to internalize how general semantics works. I could give an overview, but I wouldn't trust myself to get it all right. But a few major features did come up in the breadcrumbs Heinlein left for us. These included use of mathematical logic, pedantic accuracy even when it overcomplicates things, a weird hostility to the verb to be, which it considers both imprecise and overly dogmatic, and the biggest one of all, Heinlein writes that the language does not distinguish between nouns and verbs. That's right, Speedtalk is a verbless language. Reality isn't made of nouns and verbs, says Heinlein. It's made of, quote, space-time events and relationships between them. Now, the word event has specific meanings in several areas of physics, but of course it can't be that simple because general semantics has its own definition. In general semantics, an event is what we would call a noun at a particular point in time. So Bob Jones is a noun, but Bob Jones in 1994 is an event, and Bob Jones in 2004 is a different event. Why Bob Jones, especially since he died in 1968? I have no idea. That was just the example given on the Institute of General Semantics website. Yes, there is one. But how does that work, having a language without verbs? That took more detective work than I have time to describe here. It was a lot of thinking and parsing it out and reading the General Semantics translation of the Bible. Yes, that's real too. But I think I figured out the secret. And it's really just pedantically insisting that things that look like verbs are actually something else. Verbs that represent position or orientation are analyzed as adpositions, not prepositions or postpositions because they can go anywhere. But the real trick is that this can also apply to verbs of motion. And this is where Speedtalk's pedantic accuracy is not a bug, but a feature, because Speedtalk also doesn't distinguish between space and time. Einstein's theory of relativity regards space-time as a unified whole, and that means Speedtalk also insists on regarding space-time as a unified whole. This sounds like it would confuse things, but in this case it doesn't. If there's a ball at point A and a ball at point B, those are two space-time events. If a ball rolls from point A to point B, those are also two space-time events. And in relativity, there's no fundamental difference. Both pairs are separated by space-time intervals that are calculated in the same way. So if the first one can be an adposition, so can the second. But when you allow this, it doesn't just work for motion. Verbs that represent states are parsed as adjectives, but verbs that represent changes in state can be adpositions relating before and after states. Also, creation and destruction are considered changes of state. That's a quantum mechanics thing. And there was one other category I needed. Verbs of communication, and some other ditransitive verbs like to give, are analyzed as nouns. Or more specifically, the subject of the sentence is the message itself, which is then subject to an adposition of motion moving from sender to recipient. I'd gotten myself into the amateur conlanger's mindset. It was going well so far, but I wasn't done yet, because even if I'd figured out how to get rid of verbs, I still had to deal with word order. It's not entirely clear, but Speedtalk seems to have free word order. This is kind of reading between the lines of the story, but if nothing else, you have the issue that I mentioned earlier, that effectively random phonemes have to be arranged into coherent syllables if at all possible. and that means the governing principle of word order is not syntax. The problem is that despite having free word order, Speedtalk is also completely non-inflecting. If every phoneme is a different word, you can't very well add more phonemes for inflections. How was I going to solve this? Once again, I had to fudge it a bit. I decided that even though words, that is, phonemes, don't inflect, sentences might. And even though there's a free word order, there could still be a default word order. And what is that word order? It's essentially topic-headed. A Speedtalk sentence will describe a thing, or event, and its relation to other events. So it's topic first, nouns precede adjectives. If there's a before and after, before comes first. If there's a ditransitive not verb of communication, message comes before sender, comes before recipient. And if a sentence is constructed that violates those rules, you have to add an extra phoneme called a particle of inversion to signify that. It's actually a little like noun cases, except they apply to a whole sentence. So, in the basic grammar of Speedtalk, a simple sentence is sort of like throwing a bunch of phonemes in a bucket and turning them into what other languages would call a single word. If the Phonotactics allow it, you construct it by putting the phonemes in the default word order. If not, you rearrange them into a coherent syllable and add the additional phonemes for inversion to indicate the correct reading order. More complex sentences can occur if one of the semantic units of the sentence is actually a phrase. This can happen with technical terms, as I'll explain later, and it can also happen with states that are adjectival phrases. For example, if you like Rhapsody in Blue, then your state is not liking, but liking Rhapsody in Blue. Sentences are constructed so that adjectival phrases like this are separate syllables, with appropriate spacers when needed. And note that we do see multisyllable words in Heinlein's transcribed conversations, so this still fits what he wrote. A couple other features of Speedtalk's grammar. Evidentiality is very important, and there is a series of evidential particles that are not required but are strongly encouraged. This goes back to general semantics. General semantics doesn't like absolute pronouncements, even for such obvious truths as the flower is red, instead preferring to say, the flower appears red to me. This is horribly clunky in English, but Speedtalk does it in just 3 words: flower, red, and the evidential for perceived by the speaker. On the flip side, Speedtalk also allows you to drop any words that are not necessary to understand the meaning of the sentence, since, it emphasizes speed. So the evidentials can be dropped if they can be reasonably inferred, which would probably apply to the flower example. Similarly, Speedtalk speakers wouldn't want to waste time with proper names, so it would use them as little as possible. But it would also want to avoid getting its pronouns all mixed up. What to do? Heinlein did include one proper noun in his sample texts, New Jersey. And I found it interesting that it was preceded by the only apostrophe in the samples. In context, I interpreted that as a glottal stop, and specifically the aspirated glottal stop, since I was already using the plain glottal stop as a spacer. And in context, I interpret it as an assignment operator. Speedtalk has explicit referencing and dereferencing of pronouns like a programming language. And yes, I kinda stole that from Lojban, but it's exactly the kind of thing that Speedtalk would come up with. And I'd done it. I'd solved the grammar. Now there was only one step left to crack the entire case. How do you make a functional language spoken by highly intelligent superhumans work with only 1,000 words? But luckily, Heinlein already answered this one. You don't. You use numbers. Speedtalk's 1,000 phonemes form the basic vocabulary, the most common words. Also, another thing I learned from doing the translations was that function words should be vowels to make it easier to build syllables. Heinlein was inspired by Ogden's Basic English, which condenses English into 850 words. But even Ogden concluded that you need an additional set of technical terms for any specific field of study, something that Orwell also copied in Newspeak. Since Speedtalk is already overloaded with phonemes, Heinlein just gave every technical term a number and left it at that. Speedtalk's number system is base 60. Why not a power of 2? Well, it was 1949. We barely understood the value of binary in actual computers back then. I set the 60 digits of the number system to be far apart in the space of phonemes. No tone, no length, no articulation, to be more easily distinguished from one another. A word that is not in the set of basic vocabulary is represented by a 3-digit number preceded by the special particle sh, parsed as a separate syllable. This gives an additional 216,000 words to work with, enough to compete even with English with all of its technical language. And that's it. That's Robert Heinlein's Speedtalk. Except... No, this is wrong. It's all been a wild goose chase, and Heinlein led me on every step of the way. It doesn't matter how well I build Speedtalk, because it can't work. Mathematically can't. The fidelity you need is impossible. Not in a crowded room or over noisy phone lines. No one will be able to understand it. Just when I thought I'd solved it, the trail is vanishing before my eyes. Okay, enough drama. There's one big problem with Speedtalk as Heinlein described it, and it's one that I mentioned in my original podcast episode. Fidelity. Speedtalk may work fine if you're talking in person in a quiet room, but do you really think you could distinguish 1,024 phonemes accurately over noisy phone lines, even with superhuman intelligence? With aliasing, where 2 or more different phonemes could equally make sense in context, even superhumans will be stuck. There's just too much ambiguity. But no, I couldn't let that stop me. I'd come too far to give up now. I had to find a way to fix it. I followed more leads. I racked my brain and dug through the literature. I went out in disguise. I contacted the irregulars. I threw my archenemy over a waterfall. Wait, no, that was Sherlock Holmes. Okay, it makes a nice story, but that's not really what happened. The truth is that solving the fidelity problem was my original idea for the language, and I already knew what my solution was. Speedtalk has built-in error correction. You see, I was originally going to make this a math video, similar to last year's Gopt Jam, but I just didn't have time before the Summer of Math Exposition deadline. And also, the longer I worked on it, the more this video wound up not being about the math, but more about constructing Speedtalk as Heinlein envisioned it, so the focus had to change. But the error correction is still there because the fidelity problem is still there. The thing is, it's not mandatory. Speedtalk does probably work in a quiet room, or in writing for that matter, so I didn't need it to make this video. I did design the error correction algorithm though, and it is as cursed as everything else put together because it's not an easy error correction code like a Hamming code. Oh no. Speedtalk uses a Reed-Solomon code. Reed-Solomon codes are very popular codes that let you do error correction directly on alphabetical characters, not just binary. And they're everywhere. They're used in DVDs, QR codes, and even communication with spacecraft. But they're also horrendously complicated. Senior level college math, if not graduate level. In fact, I'm not even going to explain it here because if I took the time to explain how it works and why it works, and all the background knowledge I needed to make it work, this video would be over an hour long, I am not kidding. I'm just going to throw up some slides here showing a quick and dirty version of how it works, and I will hopefully be making a dedicated video about it in the future. Pause the video if you really want to know how to do it. But while that's running, I have one more brief comment. It may sound crazy to do this much math to encode and decode error correction in the language. Now, first of all, it's a cursed conlang contest, so why not? But also, it still makes sense in Heinlein's story. Heinlein writes that the new men, the people who speak Speedtalk, can think 20 times as fast as a normal human, Meanwhile, Speedtalk, even though it encodes a lot of information, is still spoken at normal speeds. So I'd say the new men have the brainpower to spare for this. So, after all that, I had truly solved the case. This was Speedtalk as Robert Heinlein envisioned it. Or at least as he would have envisioned it if he knew modern information theory and computer science. Now, all that was left was to translate the text of the Twilight meme, because it's supposed to be cursed after all. This also took some doing. Most notably, what does it mean in a general semantic sense for Edward to be a vampire? Remember, general semantics doesn't like the verb to be. It's not obvious, but I eventually settled on Edward belonged to the class vampire. And after sorting out a few more things, this was the result. Note that it includes a pronoun assignment at the beginning. And as short as it is, there is no way this is going to happen in one take, or even one take per sentence. To Edward, to not arrow. Except a native Speedtalk speaker would talk at a normal speed, which is about 16 phonemes per second, which would need a video of its own to explain. So it would sound more like this. To Edward, not arrow. I really want to do Speedtalk justice because it's a major signpost in the history of conlanging that hasn't been fully constructed before. So I'm planning to do a full video series on it to cover all the stuff I glossed over here and more. Like, I had a whole section about Speedtalk poetry where I was going to turn the translation text into different poems by changing the tones, but the pronouns just didn't work out right for that. So, if you want updates on that, subscribe to my channel, and if you want to support me in this and my other endeavors, consider joining my Patreon. And until next time...